Today we are going to evaluate the definite integral shown, which is the integral of ln cosx dx between 0 and pi by 2, and we're going to ignore the discontinuity at pi by 2 and assume that it can be dealt with. And so we see that by the King's property, the integral we want is the same as the integral of pi by 2 minus x. And so our integral is the integral between 0 and pi by 2 of ln cos x, which is the integral between 0 and pi by 2 of ln cos pi by 2 minus x, which of course is the same integral with ln sin x. And so twice the integral is the integral between 0 and pi by 2 of ln cos x plus the integral between 0 and pi by 2 of ln sin x dx. And so when you add the logarithms, you multiply the numbers. And so twice the integral is the integral between 0 and pi by 2 of ln sin x cos x. Sin 2x is 2 sin x cos x. And so twice the integral is the logarithm of half times sin 2x, which is the integral between 0 and pi by 2 of ln half dx, plus the integral between 0 and pi by 2 of sin 2x dx. And we discover that the first bit, the integral between 0 and pi by 2 of ln half x dx, as you follow along there, is just pi by 2 ln 2. And so twice the integral we're looking for is pi by 2 ln 2, plus the integral between 0 and pi by 2 of ln sin x dx. And so twice the integral we're looking for once again is pi by 2 ln 2 plus the integral between 0 and pi by 2 of ln sin 2x dx. And the integral between 0 and pi by 2 of ln sin 2x dx, if we make the substitution u equals 2x, as I've shown there, this in actual fact is the most important step of this entire evaluation. We discover du by dx is 2, so that means that dx is half du. And so if we also substitute the limits and go from pi by 2 to pi, the integral between 0 and pi by 2 of ln sin 2x is the integral between 0 and pi of half of ln sin u du. And in the next slide, we are going to make the trivial switch from u back to x again. And so half the integral between 0 and pi of ln sin x is half the integral between 0 and pi by 2 of ln sin x dx plus half the integral between pi by 2 and pi of ln sin x dx. And so I think I've repeated myself there actually. But if you look at the middle term, half pi by 2 down to 0 of ln sin x, that in actual fact is half of the integral we're looking for. And so twice the integral we're looking for is pi by 2 ln 2 plus half of I plus this other integral here between pi by 2 and pi of ln sin x dx. And so if you look at the second row I've written there, where I'm looking at the integral between pi by 2 and pi of ln sin x, I'm asserting that that is the same as half I, which is between 0 and pi by 2 of ln sin x dx, because if you look at the graph of the sine, that is the graph of y equals sin x between 0 and pi, you will see that it is symmetrical about the line x equals pi by 2. So the area on the right-hand side is the same as the area on the left-hand side, and so the integral between pi by 2 and pi of ln sin x is the same as the integral between 0 and pi by 2 of ln sin x dx. And so that means that 2I equals pi by 2 ln 2 plus half I plus half I, so that 2I is pi by 2 ln 2 plus I. So the value is I equals pi by 2 ln 2. And now I think we've earned a cup of coffee.